Hello, hi guys, welcome back to the channel Ask Sid How To. So, today we'll be learning PCR troubleshooting, that is, when your Agarose gel doesn't show any bands when you run a PCR product. So, what could be the issues that we'll be learning today in this video? So, you must be knowing about PCR. So, many of you must have faced this issue that even after loading and making the gel properly, you don't get to see the bands. That means your template has not amplified properly. So what could be the reasons that we'll be going to see today? So first of all, the common reasons for failure of a PCR, right? First one, the major primary causes of missing bands could be template issues, reagent imbalance, protocol factors, right? So template means the poor quality of your DNA might you know uh, cause this missing bands, or maybe the that DNA has degraded, or in the presence of any PCR inhibitors like some salts or phenols, the reaction won't work. So that could be one of the reasons of no bands in the gel. Another reason could be the reagent imbalance. So when you have insufficient MgCl2 in some of the reactions, insufficient MgCl2 could be the reason for that. DNTPs, if they are imbalanced or they are expired, Tag polymerase enzyme is expired, or if it is added in less amount, so that could be also the reason. Protocol factors like incorrect annealing temperatures, insufficient cycles, maybe uh, you have kept more cycles or you have kept very less cycles, so that's why you are not able to see the missing in the PCR bands in your gel, right? Also, the poor primer designing can be the issue why you are not able to see the uh, gel bends. So these are the primary causes. Now we'll see one by one what happens exactly with what are with each issue. First one, we need to evaluate the DNA template. So whenever there is a ideal isolation, we before the PCR reaction, we should ensure that the samples are stored properly, and we should measure their concentration. Okay, this ratio is A260 by A280 should be having a proper re- result. And along with that, if we are still having any doubts, we should run the DNA into agarose gel. Some 0.8% of agarose gel you can use, so that you get a proper band. If you are getting some smears, you can be sure that your DNA is already degraded. So if it is possible, you go for another round of DNA isolation from whatever the sample is, blood or tissue or whatever it is, right? So next is elimination of contaminants. So what could happen uh, from your DNA isolation? We use several different methods for isolation, salt base, phenol base. So if something is remaining in your DNA and that carryover is not removed properly, that could also inhibit your polymerase, and that could stop the PCR from giving you proper bands. Another reason could be a very basic things. We most of the people just ignore such issues like this cannot happen, that is storage of DNA. So whenever you are storing DNA, make sure it is stored in T buffer or nucleus free buffer. Stored in the sense, after your elution, whenever you are storing in the form of dilution, so either you dilute it in T buffer or nucleus free water. And of course avoid repeated freeze thaw cycles, okay, because that can lead to shearing of the genomic DNA, right? So these are very small basic things that we should keep in mind, so that we you know don't get issues afterwards, right? Next is optimizing the primer design. So whenever we are designing primers, maybe you are doing a normal primer designing or the trams primer designing, the basic things you should be very much careful about are the length of primers. Don't go for too short or too lengthy primers. Aim it for 18 to 25 bases. Okay, GC content is very important again, because if it is exceeding 60%, 65%, it won't be the you know your GC bonds will not be breaking properly. So that could be one of the reason. And if it is not breaking, if the DNA templates are not getting separated properly, of course there will not be any amplification, right? So that is also very important while designing the primers. Keep in mind it is between 40 to 60% only. Next thing is you should avoid primer dimers and secondary hairpins. So when you are designing using several tools like Blast, I have also mentioned many other tools in my videos. So I'll give you a link in the end of this video, so you can check all those tools. Like there is one MFE, then there is UCSC in Silico browser, Blast is there, right? So we have several tools are available nowadays. You can check very easily whether your primers are forming dimers. If it is forming too much dimers, you should try you know changing the length of your primers. Okay, so that way you can avoid the primer dimers before even ordering. So when you have actually ordered, you don't need to take headache for these things, right? And of course check the specificity. When it is specific, that means it is not binding anywhere else, so it will give you a proper result, and it will bind to a proper specified place where generally your SNP resides, right? So next is refining the PCR conditions. So now once we have seen, okay, my DNA is fine and my storage conditions are fine, I have not repeatedly freezed or thawed them, then my primers are also fine, designing is proper, everything is proper. Now next is refining the PCR conditions. Okay, so this way we troubleshoot the PCR reactions one by one at all, once at all the things. You cannot think, okay, well, I'll do this also, I'll do that. You have to go one by one. So when you are doing a troubleshoot, you have to do one step at a time. So next is PCR conditions, gradient PCR. So most of the labs, they have been taught to set up a temperature gradient. Okay, temperature gradient of annealing temperature, as well as you can set up a temperature gradient for your denaturation temperature. So annealing temperature, of course, you will be getting a clear picture whether your primers are binding properly at 57 degree or they will bind at 65 degree. Okay, so you should be putting one gradient PCR to get a proper temperature gradient, right? Then accordingly you can go and select, okay, which one gives me proper bands without any dimers and without any non-specific binding. Then I'll go for the next step. Okay, along with this, when do you need to use this denaturation temperature gradient? That is one question I want to ask you. So let me know in the comments if you know when you should go for a uh, denaturation temperature annealing, and let's see who can answer that, right? And if you are not able to answer, you can also ask me in the comments, I'll answer that. Next is extension time. Some generally we keep 5 minutes or 7 minutes of extension time. So if it is a larger product, of course you have to increase the time depending on. So if it is like 1000 base or something, so accordingly you have to increase the time also. So make sure you keep the extension time accordingly. Generally for 500 600 kb for sample OFOR, you need 5 to 7 minutes of extension time. That is more than enough. Then number of cycles, usually 28 cycles are minimum that we keep. It ranges from 28 to 30 or 35 is the max. If you are going more than 35, make sure you have added enough of the template and polymerase and everything, all the reagents, so that it doesn't lag. Otherwise what will happen, suppose uh, you have kept 35 cycles and the reagent is sufficient only for 34 cycles. So when it the template divides again for the 35th time, it won't have any of the PCR these reagents, so it won't amplify. And if it is not amplifying, of course, because of extra cycles and less number of reagents, less amount of reagents, it will not show you any amplification in the gel, right? So make sure if you are keeping high number of cycles, 35 cycles, you should have ample amount of reagents as well, right? Usually 28-30 cycles are enough, right? Next is magnesium concentration. Optimization should be done of MgCl2 also, generally between 1.5 to 2.5 millimolar for better enzyme stability. Again, magnesium chloride has to be added only when you are adding everything separately, like DNTB separate, tag separate. If you are having some master mix, ready mix is also available nowadays. So if you are using them, most probably you won't need any extra MgCl2, right? So next is verifying reagents and the equipment, of course. So now I'm done with the PCR reagents as well, I mean the PCR conditions. So remaining is now I will be checking my tag polymerase, whether it is expired or not, whether it is active or fresh. If it is not, you of course have to get a new aliquot. So it is recommended by the company also that whenever you get your tag polymerase and all these things, you keep aliquots. Okay, make aliquots. Don't keep the main tube as the for active usage. Make a aliquot and keep it for active usage, and the remaining one you store in -20. Next is your same way your DNTP mix. Okay, you have to make this accordingly 10 micromolar of concentration, and make sure you are using it fresh, and of course make aliquots for them also. Nucleus free water, of course, you should be nucleus free water, and you should be using sterile tubes, because this is very important if water is having contamination, because most of us we just ignore water, but this is also having issues. So make sure you are using sterile tubes, and carefully you are pipetting out nucleus free water. Okay, next is thermal cycle. Of course, this is the least possible condition where you can doubt anything, because generally it doesn't it doesn't have any issues most of the times. Most of the times we'll have issues with dimers and our own reagents only, but you can of course doubt the thermal cycler also if you feel like everything you have checked correctly properly, and only the issue is with the thermal cyclers. So of course these things has to be checked. So gel troubleshooting, now all these things are done. So maybe my PCR is perfect, my template was okay, my you know uh, this reagents are okay, water is okay, no contamination, everything is fine, PCR conditions are fine, cycles, temperature, everything is fine, still I'm not getting the bands, then the fault could be in your gel, the agarose gel that you have prepared. So make sure the agarose gel that you prepared for PCR, generally we consider minimum 2% gel. And if you have for example very nearby bands, for example when I run a multiplex reaction and I have bands at around 200 and 170, so to visualize them I need to prepare a much higher percentage of gel, sometimes 3.5% gel also we need to prepare. So make sure the gel you are preparing is prepared accordingly, and the buffer you are using to prepare gel is also fresh. Okay, of course check their pH, it should be around 7, so that is also very important. Make sure you have added ETBR when the gel was prepared, little bit cool, right? And check the voltage also. uh, doesn't have, I never got any issues with the voltage. Generally I increase the voltage when I need to run it fast, otherwise voltage generally doesn't have any issues. Dyes, and also when you are loading dye, ladder quality should be maintained. So mainly if you have prepared your gel properly, 2 to 3% is fine for most of the PCR reactions. But when your band sizes are very much near, make sure you make a higher percentage of gel. Okay, and even for when you want to check, I'll give you one extra advice. If you want to check your primers, dilution that you have made are alive or not, that means is it working or not. How do you check? So you just run them, okay, with the loading die, any die you can use, whichever you use for the PCR product, same one, maybe 2 microliter of your dye and 2 microliter of your this primer you can use, and you load into a 2% or higher percentage of gel. And if you see a band properly, that means your primers that you have diluted are alive, they are fine. If it is not, then you can be sure that your dilution has degraded, so you need to make a new dilution. Or if it is the stock, then the stock is also degraded, you need to procure a new stock, right? So this way you can troubleshoot your no bands situation, right? And with a quick troubleshooting workflow we have here is template, confirm the quality and purity of the DNA. First thing to be doubted. Second thing to be doubted is primer. Verify the design and the concentration. Next thing is optimizing your annealing temperature and your cycle count. Next is checking the reagents. Is your reagent degraded or not? You need to check all the enzymes, right? And the final one is gel. Confirm the setup, the stains, the percentage of gel, all those things need to be checked whether it is up to the mark or not, right? So in the conclusion, what we can say is systematic troubleshooting is the key to mastering PCR. Always change one parameter at a time. Okay, so once you are troubleshooting also, go one by one. Okay, start from the beginning like this. First you go for the DNA checking, primer checking, conditions, enzyme, gel, right? If you change all the parameters at once, then you won't know which one worked for you. Okay, so systematically if you go, you will have a, maybe you can note this down, or right, or take a screenshot if you need, right? So this way you can troubleshoot your PCR very easily, right? Document every optimization step for the reproducibility. Why? Because once you have got the result, make sure the same changes that you made will give the same result in the next reaction also. So 2 or 3 times if you have checked and you're getting proper result, that means you got the issue and you have successfully troubleshooted it, right? So this way you can troubleshoot your PCR, and if you have any questions you can ask me in the comment box. And do like, share and subscribe if you have not already. Share with your friends and those you think would need this. Okay, and I will link the uh, videos where I have shown how to check the specificity and all. That will be helpful for you. And I'll show you in some extra gel pictures which I have run. How does it look? I'll try to explain you. So this is one of my gel pictures. This is a multiplex reaction. So as you can see here, this is the ladder, right? And this is around 2.5% gel. So as you can see, little bit smearing is there, but this much is fine. You can see these bands. Okay, I have run different sample. This is not the same sample. And here you can see a band between, this is 100 base pair, 200. So between 100 and 200 there is one band, and one band is here you can see. So this is a heterozygous condition. Same way here it is homozygous, heterozygous, right? So at the bottom you can see this is the remaining reagents. That means I have kept, added some extra reagents, or maybe the cycles that I have kept is little bit less, so these reagents are remaining. So I can try to minimize the reagents, or I can increase the cycle to avoid kind of a wastage. Otherwise I am getting results. These bands are a little bit faint. Okay, so for these type of things you need to optimize the PCR conditions. Okay, same way here also. Otherwise your gel, if it is looking like this also, it is fine, right? So let me know in the comments if you have any questions. and thank you for your time. Bye bye.